Alright, welcome to part 2. Let's take a look at freshwater use. Here's a quiz question for you. What two regions of the world have the least freshwater resources? So this is multiple mark, obviously. Two regions. Alright, so if you picked Northern Africa and Middle East, that is correct. Northern Africa is the area of the Sahara Desert, and the Middle East also desert biome. So here's a graph showing available freshwater resources by continent mostly, and we can see that, oops, let's go back there. We can see that blue means having a lot of water available, and we definitely see that in the northern, in Canada basically, and northern former Soviet Union area, northern Asia. And let's point out something very important here. This means this is per capita per year. So cubic meters of water per capita per person. And one of the reasons that this is so high is not necessarily because they have so much available fresh water, but because they have such a small population size. But here we see a rainforest region along here in northern South America, and also the rainforest area here in middle Africa, and rainforest areas here in the South Pacific. So they also have a lot of fresh water available. But here we can see the dry areas of the Sahara Desert and the Middle East. And so these are areas where they have to do a lot of irrigation to grow food. Because they get such good sunlight, it's potentially good for growing crops as long as you have a source of water. And when you take that water from the ground, then you bring on other problems that we'll discuss in just a little bit. So this is water use per capita of selected countries, and the global average is 328,366, and that is gallons per person per year. We can see the US is pretty high down here, about double the global average, and Spain and Canada also being very high. A lot of these countries here in Western Europe, Germany, France, and we see China and India much lower compared to the US. Now, do you expect that to increase as their economy increases? Most likely, yes. What is the biggest use of water in developed countries? This is a multiple choice question here. So, if you said electric power, you were right. If you said agriculture, that's actually the second biggest use of water. And so what's the deal? What do we use it for electric power plants? It's used in the condenser part of the plant to cool the steam back to water. And the high pressure steam is used to turn the generator turbine. So here's a graph showing water use in different areas. Purple is public water supply, so this would be like Santa Barbara. We get our water as a public supply. You just turn the tap and you're connected to the city's supply. Rural would be those places that are taking it from the ground through wells, like myself. Irrigation, also, well, this is just water being used to irrigate crop fields. Thermoelectric, now that's the one we were just talking about. This is where you're bringing water in to cool your electric power plants. And industrial is not that large compared to the other ones, and that just means using it for industrial processes like manufacturing plants, factories, things like that. So how do we use water? One is called consumptive use, where the water is removed from an aquifer or from a surface body and not directly returned. So agriculture uses about 30% of the water in that way, and most of this water evaporates from the field or transpires from plant leaves. So even though you might be taking that water from the ground and then applying it to the surface, it's not really finding its way back into the groundwater because it's either evaporating or being taken in by the plants, and then the plants end up transpiring it back into water vapor. And domestic use, this is about 10%, and in Santa Barbara, this water gets discharged to the ocean, and we'll see that process when we visit the El Estero wastewater treatment plant. And industrial, 10% for manufacturing plants or factories. And non-consumptive use means removal of water is only temporary. So it is getting directly returned to where it was taken from. And this is mostly what we see with our thermoelectric power plant cooling. The water is taken in from a river and returned warm. And we call that thermal pollution, the fact that it's being returned warmer than it was. Because that can affect plant and animal life. So here's a question: where does the water for these Kansas crop fields come from, and how does the government subsidize it? So it's pretty amazing. This is grasslands, right? There's not a whole lot of rainfall, yet we see a huge amount of agriculture happening there. And the answer, of course, is that it comes from the ground. And the government subsidizes it. I just learned about this today, actually, doing a little research, where back in the 50s, the government gave lots of money as part of what was called the New Deal to get the economy ramping up. And oops, I misspoke for a moment there. The New Deal was after the Great Recession, before World War II, trying to get the economy to ramp up. And so anyways, what they did is they helped provide money to farmers to put in electric pumps for extracting groundwater for irrigation. And that those contracts gave them a very, very, very low cost or rate for their electricity. And those contracts were about 50 to 100 years long. So most of these, or many of these farms, are still getting extremely cheap electricity for pumping groundwater. And so that's called a government subsidy, where the government basically pays for them to have cheap resources. And let's also refer back to that thermoelectric cooling. Which of these towers is emitting pollution? So you might look at this picture and think that they're all emitting pollution because you see smoke coming from all of them. But actually, what you see coming from this is just water vapor. And this is called a cooling tower. It's part of the power plant. This is a coal-fired power plant. So what happens here is you're burning coal and you are producing steam from that. And the steam is high pressure, so it turns a generator. And then that steam has to get cooled down again. And so we use water that you bring from a local river to help cool that steam back into water to repeat the cycle within the plant. But that cooling water that was that absorbed water from the steam, that cooling water is too hot to go back into the river. So you put it into this cooling tower where it's allowed to evaporate off. And in the process of evaporating, it cools off. And when it gets cool enough, then the water can go back into the river. These stacks or towers that you see over here, these are emitting pollution, primarily CO2, and that's coming from burning of the coal. And some of that pollution would also be in the form of sulfur dioxide, which is a component of coal. But nowadays we have technology to remove a lot of that sulfur before it goes out of the smokestack. So referring back to, that's kind of a preview into some of our coming units. But to go back to that groundwater extraction, there's a huge aquifer called the Ogallala Aquifer, which you can see it's underneath Nebraska, Colorado, Kansas. It goes all the way down into Texas. And here is the thickness of that water as far as we know it, of that aquifer. And so the darker color, the more water there is there. And it is the world's largest aquifer, and it's mostly water from the last ice age, which was about 10,000 years ago. And it makes agriculture productive here, the breadbasket of America. Without this water, we would not be able to grow all the food that we do. And it is being depleted unsustainably for irrigation use. In fact, it's 8 times more is removed each year than is replaced. So obviously that's not sustainable. And we see areas then where the water table has decreased. And this map is showing changes to the water table from 1980 to 1995. The areas in orange represent drops of up to 40 feet in only 15 years. And so these areas in red are where we've seen the most rapid drop in the water table. So what's the deal with groundwater extraction? Well, some facts here. 1 in 3 humans rely on groundwater for drinking, like myself. 99% of the rural U.S. relies on groundwater for drinking. And extraction from aquifers is increasing, especially in developing nations whose agriculture intensified with the Green Revolution. So we see that in many cases the supply is higher than the demand for groundwater, so green is okay, no problemo. Demand equal to supply, again that's saying okay, no problem. But here, when you use this word or see this word overdraft, it means you're taking out more than you're allowing to go back in, or you're taking it out faster than nature puts it back in. And so we can see that happening in the Ogallala Aquifer over here. And we see big time happening in the Middle East. So this is Pakistan in that area. and also in parts of Spain, and of course China over here. This is a graph showing water tables in Gujarat, India, and countless places around the world and the US are dropping steadily. So what we have here is 1976, the water level, and this means water level in the ground. And 2008, so we can see that it's dropped. And they were taking several measurements. Blue is the maximum, red is the minimum, and black is the average of those. And we can see it varying seasonally as you have groundwater recharge occurring. So this is really a bigger threat than surface water depletion because aquifers recharge very slowly. And we are making more withdrawals than deposits, and the balance is shrinking. This is also referred to as water mining. And water tables in some areas are falling by 1 to 3 meters or 3 to 10 feet per year. So that's pretty drastic. And the Ogallala Aquifer has lost over time the equivalent of the yearly flow of 18 Colorado rivers. When you are extracting, so when you do have over-extraction, you can get what is called subsidence. And this is when the ground actually lowers. It can happen when aquifers become dry, forcing the aquifer rocks to bear more weight and crush and become compacted. So in this diagram here, we're seeing that this is how high the ground used to be in 1925. In 1955 and 1977. So this is not about erosion. This is about the entire surface of the land getting shrinking, going lower and lower and lower relative to sea level. And this one happens to be in the San Joaquin Valley of Central California. And yeah, so this is primarily a result of overdrafting water for irrigation. We also see this subsidence in portions of Mexico City where it has sunk 9 meters in the last century. And here we just see some general changes of the ground shifting as a result of some of that subsidence. Sinkholes are an extreme example of subsidence that can occur when water tables drop due to extraction outpacing recharge. And recently a person in Florida died, or this was about a year ago, when his bedroom fell into the ground. Imagine that. But you have subsidence, which can occur or you have, so you're getting like subsidence underground, but you still have this crust of ground at the surface, but because this no longer being supported by ground underneath it, at some point it could just give way and just fall. So that's a real occurrence, a real concern. And you also have another problem with lowering water tables, which is saltwater intrusion. And this occurs in coastal areas when there's an over-extraction. And so we see that dip in the water table right around there. And when that dip gets too low, then you can get salt water coming in and mixing with your fresh groundwater, and that creates a real problem because salt water is basically useless for human consumption and irrigation, and it can ruin the aquifer. So at that point, you have to either dig a new well or pay a lot of money to desalinate the water. The Santa Barbara system is actually really great because we have such a variety of sources. We get most of our water from Lake Cachuma, or Montecito area gets it more from the Gibraltar Lake area. And we also have lots of wells, municipal wells around town. And you can see some of these when you're driving around. They won't be labeled, but they are there. And we also are pursuing a reverse osmosis desalinization plant, and that would help provide our needed water in the future. So here's a list of some solutions that we can use for reducing our water use. In the residential section, you can install low-flow faucets and appliances. You can use automatic dishwashers. Replace your lawns with native vegetation called xeriscaping. We'll see that in coming slides. And if you keep lawns, water them at night where there's less evaporation. And you can recycle gray wastewater, which I'll also show you. So here's an example of xeriscaping, and xeri means dry, so it's landscaping with drought-tolerant native vegetation. And we see this happening more around Santa Barbara. And you can also do what's called gray water, and which means you're saving water by reusing it for irrigation. So here you see this shower water, or sink water, or laundry water, which is, rather than going to the sewer, it's going instead to watering your trees. So I've actually did this in my own home. This is my bathroom as I was doing some construction on it. So this is a pipe coming from a toilet that's right over on the other side of this wall. And to make a long story short, we ended diverting our water so that we could have two water lines, one from the showers and sinks, which could be used on our trees, and the other one from our toilets, which has to go to our septic tank for treatment. So I had to cut into the slab here, and this is just showing how all these pipes are underneath the concrete, in the dirt underneath. So it's pretty hard to do this in most homes without making a big mess. This is where the pipes are coming out of the water, and here you see my two lines. Well, you kind of see things are a little bit convoluted here, but you have one line for the toilet water and one line for the shower water. And this shower water line here is going out to my trees, and that's what gray water is all about. So you can also, here's some potential ways of using less water in agriculture, using high efficiency irrigation techniques like the drip line irrigation that we learned about. You can use reclaimed water from wastewater treatment plants, that we'll see that at the Elistera wastewater treatment plant. You can line irrigation canals to prevent leaks. You can level your fields to reduce runoff, choose crops appropriate to the climate, eliminate government subsidies of inappropriate crops and methods, and you can also try using new GM crops that might be engineered to use less water. So I'm just going to make a mention about this government subsidies. The farms pay much less money per gallon than households do because their water use is being subsidized by the government. Although this year I've heard the government is withdrawing some of those subsidies, and that's putting a big crunch on farmers. So because of the drought, this is the government's way of forcing farmers to try to get more creative with using less water. So we are almost certain to see a huge increase in food crops coming from this next year's harvest, because farmers are going to have to be spending more money to irrigate the fields. Okay, and as far as industry goes, how could you save some money there, or save some water and money? So you can shift to processes that save water. You can invest in repairing pipe leaks, so dripping, whatever it might be, dripping faucets within your facility, and you can recycle gray wastewater if possible. As far as economic approaches, so talked about market-based, so ending government subsidies, which means make water a commodity whose price actually reflects its cost. So it's not taxpayers paying for farmers to use cheaper water. You could also potentially privatize water supplies, which would allow companies to own water and be able to sell it. And maybe decentralizing the control over water, removing big government control of water. Some people feel like that could allow a more efficient management of the water. But many of these strategies risk increasing the gap between the rich and the poor. Once you go into talking about privatizing things, often it means that corporate heads are making more money, or corporations in general, and the people who are having to buy that water are having to spend more than their usual amount. And solution number 3 is desalination, which is the removal of salt from seawater to create fresh water. And it can be done by reverse osmosis, which is filtering water by forcing it through an expensive membrane with tiny pores. And some people do this in their homes, in their kitchens. You could also distill the water, which means boiling it and condensing the pure steam back to water. But both of these require a lot of energy and therefore money. But perfecting this technology would mean the oceans could provide us with unlimited fresh water. And most of the world's 7,500 desalination plants are in wealthy oil states of the Middle East, where water is scarce enough to make desalination economically feasible, and there is plenty of money from oil. And we are also going to be building a plant like this in Santa Barbara. We did this actually in 1991. Santa Barbara spent $34 million to build one of these plants. It was operated for 2 weeks, but then shut down because it was not worth the expense of operation. But now we are talking about bringing it back.